Hello everyone, welcome to School Math Simplified. As you know, we are doing chapter 3 and we are continuing from the page number 61. That is the idea of a base, that is the Egyptian number system, which is depicted from the Roman number systems. And I hope you remember that we have discussed the landmark numbers there. Like 1 is represented as 1, 5 is represented as B, and 10 is represented as X. These are called the landmark numbers. Okay. So now what is the Egyptian style? Egyptian style which was introduced around 3000 BCE, and they create it with the help of collection of pebbles which were in the powers of 10. That means their landmark numbers are 10 raised to 0, which is 1, 10 raised to 1, which is 10, 10 raised to 2, which is 100, 10 raised to 3, which is 1000. Fine. That means all the numbers are in the multiple of 10. So please keep this in mind. This is very important to do the next figure it out, the Egyptian number system. So what were their symbols? These were their symbols. This thing that you need to note with you because many of the figure it outs are based on these symbols and the powers. Fine. So please have a look on that, how it looks like 1, 10, 10 square, 10 cube, 10 4, 10 5, and so on. Okay. So if we need to elaborate 324 in the series of 10 exponents, so it will be represented as 100 plus 100 plus 100, right? Plus 10 plus 10 and plus 4. Yeah, you can write it as 300 plus 20 plus 4. This is also acceptable, right? But make sure it should be in the powers of 10, right? You can further elaborate that. And what signs will it be there? So see, 300s means you will apply this sign thrice, okay? So is the sign 20, that means two tens, right? So it is 9, and 4, that means 4 times 1. This is the symbolic answer of Egyptian number system. They have given us a few questions to attempt. So I'm giving you the hint how to elaborate, and the symbols you will choose from here wisely. Fine. I'm doing first two questions for you. 10458 is the first part of this question. And how to elaborate it? See, 10,000, fine, plus 100 plus 100 plus 100, 100 plus 10, 10, 10, 10 and 10, and then lastly 8. You can write it as, if you want to compact this elaboration, you can write it as 10,450 plus 8. Okay? This is for symbols. You can easily make the symbols from here. This is the expansion. You can easily write the expansion like this. So the symbols will be, see, 10,000 means 10 raised to 4. This is a symbol, right? And 400, that means 4 times 100. This sign, 4 times. 1, 2, 3, 4. 50, that means this symbol 5 times. 1, 2, 3, 4, 5. And lastly, so it will be 1, 2, 3, 4, 5, 6, 7, 8. So this is the symbolic answer of this question. This is called Egyptian system. Fine. Try other questions of your own. The symbols are here and you need to express them in the powers of n. Fine. So going to the next question, what numbers do these numerals stand for? So you are given symbolic form now and you need to consist the numbers with them, right? So what is this? See, two signs of this. 100 plus 100. This means what? 100 plus 100. And how many signs are there? Six signs. Can you see that? Six signs of this. That means 60. Now, six signs of 1. That means 6. And again 10 plus 10. So, while adding it, you will get 200 plus 70 plus 6. So, the answer is 276. So, this is the answer of this first part of second question. Now, moving to the next part. Second part, this symbol. Now, how it is representing this symbol. This is the thousands, okay? And how many thousands are here? 4,000, right? This is 4,000. Yes, it is 4 times. This is 100, which is 3 times. So this is 300. Fine. This is 2. But before that, this is 20, right? So 10 2 times, that is 20. And while adding, you will get 4322. This is the answer of second part. Yep. This is how you will solve the question. You can expand the terms also. In that way, you will get the answer. So moving to the next part, that is variations on Egyptian system and the notion of base. So what is that now? They are saying instead of grouping together 10 collections of size equal to the previous landmark number, can we get the number system by grouping with the collection of 5, or we can say the size of 5. So what they are saying? Till now we have done with the powers of 10, and which is called the Egyptian number, and they are notioning the base like if we use the base 5 here, so what will be the symbols and what will be the process to solve the questions. So moving to the next page, you will get your answer. So here is the symbolic way, like 5 raised to 0 can be represented as a triangle, 5 raised to 1, that is a square, 5 square is a hexagon, and 5 cube is represented with the help of a circle, and more like you have this symbol and for this also. Like we need to express 143 in the powers of 5 now. See, this is very important now. 143. Firstly, get to know the nearest value of 5, powers of 5, which is so near to 143, which is clearly 5 cube. 5 cube is 125, which is nearest to 143 because both are the 3-digit numbers, right? So 125 plus, now you can do the calculation of your own. How much we need to add to 125 to get 143? See, this is the rough work that will you done by behind. So it will be 18. You need to add 18 here. Now split 18 into powers of 5. So see, 18, the nearest 2-digit number to 18 is 15. So how many 5s will be added here? 5 plus 5 plus 5. 3 5s, okay? And how much is left? 3 is left. So 1 plus 1 plus 1. That's all. It is that much easy, okay? And this is secret. This is our rough work. But this, keep this in your mind. This is your rough work. Okay, this is a trick for you how to identify how much is required to enter in the highest power of 5. Fine. And if we need to convert 143 in the symbolic form, which is in the powers of 5, so it will be, see, 125, which is 5 cube, right? The symbol is circle. Fine. Now 5. Three fives are there and one 5 is represented by a square. So 3 squares will be added. Okay. And lastly, one single person is represented as the form of triangle. So 3 triangles are added. So that's how we can represent 143 in the symbolic form of Egyptian form, which is in the powers of 5. Keep this in your mind. Okay. So number system having landmark numbers in which the first landmark number is always 1. Fine. So what if we are to present the numbers in the n base system? N base system means, see, this is 5 base system. Okay. And earlier we have done 10 base system. What is base now? Let me remind you one thing here. What is base value? Base and exponents. This old work, okay, we are revising it. See, base value. If we have power a as the base and power is say b, right? So this is called base value and this is our exponent. Hope you remember this. Okay, so what do you mean by base n means? When we have this structure n raised to 0, n raised to 1, n raised to 2, n cube, and so n raised to n like this. Okay, base base n means the base value will be n and powers will vary. Yeah. So the Egyptian number system is a base 10 system and the number system that we created is base 5 system and a base 10 system is also called decimal number system. Yeah. So now heading towards the next figure it out. Next figure it out. Question number 1 is that write the following numbers in the above base 5 system using the symbols in table 2. What is table 2? This is table 2. This is table 2. Fine. So let's do one by one and get the answers. Question number 1, part A, 15. 15 in the base value of 5. So 15, it is easy, right? 5 plus 5 plus 5. This is so easy, right? And 5 can be presented as square. So how many squares will be there? 3 squares. So this is 15, which can be presented in the base 5 system. Easy. One more question I'll do and others will be your homework. Now 50. 50 can be represented as 25 plus 25, right? And 25, which symbol we use here? This symbol. Lagan? Yeah. C part, 50. 50 can be, sorry, 50 is done. So we have 137 here. C part is 137. 137 can be presented as 125 plus 5 plus 5 plus 1 plus 1. D part, it is 293, which can be presented as 125 plus 125 plus 25 plus 5 plus 5 plus 5 plus 1, 1 and 1. And symbols, your homework. Okay. E part of this, that is 651. So 651 is also a part of this, like we have never used yet. We haven't yet used 5 raised to 4, so we'll use it here. 625 plus 25, 1. See, all the expansion is done in the powers of 5. See here, all the expansion is in the powers of heroes. Fine. So try it of your own. Now moving to question number 2 of the next of this figure it out. Question number 2 is there a number that cannot be presented in our base 5 system? Yes, there is a number that is 0. 0 is that number because there is no symbol there is no symbol for it. Okay, we have no symbol for 0, this number system. So now going to the next question. Nextly, they are saying number 3, compute the landmark numbers using the base system 7. So I think you are expert now to creating the base systems. So base 7 system. Base 7 means 7 raised to 0, 7 raised to 1, 7 square, 7 cube, and so on. So let's expand it. This is 1, 7, 49, 43, and so on. This is called the 7 base system. What they are saying nextly, they are saying what are the landmark base numbers for base n. So this is already introduced to you, that is the landmark n base system, that is base n system. Base n system is n raised to 0, n raised to 1, n square, n cube, and so on. This is base n system. Yeah. Moving to the next page, here is the advantages of base n system. So what are these? Because it becomes easy arithmetic. That means we can, with the help of these symbols, we can easily add, right? So how? The one numeral is given to you, this and this, to count this. See how many this symbol is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 the symbols. How many are there? 6, 7, 7 and 8. This is also 15. But here is a twist. You can not directly write 30 here. Don't write 30 here. There is a way. When you add 10 such symbols, it becomes, this is the way you use the landmark numbers in adding goals. Okay. So the answer will be in this way. Like I'm giving you an example by solving the figure it out here. Let's do it. Question number 1 is this plus this plus this and this plus this. Matlab you need to add these two numbers. What is this number and what is this number? Firstly, we'll figure it out and then we will add them. Okay. So firstly, I'm solving this part. See, what symbol is this? This is a symbol of 1000. Okay. Symbol of 1000, and how many symbols are there? 9 symbols are there, right? So it can be written as 9 into 1000 plus. Now which symbol is this? The symbol is the symbol of 100, and how many symbols are there? There are 6 in number, so 6 into 100. And how many symbols are here? They are 8. Is 1 only, so it can be represented as 8 into 1. So let's solve it. This will be 9600 and okay. Now solve this part now. This is the part of first question only. And this is a symbol of 100 again. How many are there? These are 5. So it will be 5 into 100 plus. And how many symbols are there? There are 7 in number. So 7 into 1. By adding it, we get 507. See, now we need to add both. That is 9608 and 507. Let's add it. The answer will be 51101. 5. So the numerical, the symbol form of this will be this. And how it comes, that is your homework. Okay. This 1, 2, 3. This is the answer of first question of this. Figure it out. Okay. Now moving to the second part of this figure it out. First question. Again, this symbol is of 1000. So 1 is 1000 plus this 10 times. So the answer will be 1080. And here this is 10, which is 4 times 4 into 10 plus 6 into 1. So this will be 46. So by adding 1080 with 46, you will get 16211. And what is the symbolic term of this? This will be, see, 1000 means this will be the symbol, right? And then 100, okay, 100, then 20, then clear? You will get your command over this. Don't worry and practice it fully. Fine. Now question number 2, you need to add these numbers. So, you remember that this is our base 5 system. So let's add it. How many circles are here? There are 4 circles. 1, 2, 3, 4. And then how many hexagons are there? There are 3 hexagons, right? And now 3 squares. And lastly, 4 triangles. Our answer, simple, fine. This is the way, this is, I think, the easiest way to add or learn the Egyptian numerals. Hope you enjoyed that. In the next lecture, we will learn how to multiply them and what are the processes to solve it. Okay. So for now, we are resting here. Do these questions, yes, and ask me the doubts. Thank you so much.